All right, number 16. Okay, so on this one we have a dartboard. There are 5 rings of the dartboard. Each ring has a radius of 1 inch, and so there's an additional inch for each additional ring. That's going to be 1 inch more than the previous one. So if a dart is thrown at random and hits the board, then what's the probability it will land in each ring? So dart thrown at random sounds just like a stats problem, which is pretty cool. It's like the cross section between area and geometry and stats, which is like 2 of my favorite things. So this is going to be fun. I'm going to ruin the game of darts for you, because now when you see a dartboard, you're going to be like, I wonder what the probabilities are for each one of those. All right, so if we're making this game, we want the bullseye to have the smallest area, right? Which would make it the rarest one for you to hit. And we would want the 5 ring, or the outer ring, to have the largest area and to be worth the least amount of points, right? And we would probably want to correlate the area with the amount of point values so that it would be fair, right? Yeah, which is kind of cool. Or maybe reward more for maybe the luck of hitting something like a bullseye than the stuff on the outside. So anyway, it's like game development theory, which is kind of cool. All right, so let's set this out on the table just to organize our data, kind of like an Excel spreadsheet, which is kind of fun. So first thing we want to do is find the area of the circle. So we're talking about ring 1. So it has a radius of 1. So the area would be 1 squared, which is 1 pi. So what's the area of the ring? Well, there's no part that's being subtracted from it, so the area of the ring is just going to be 1 pi. The next ring, the 2 ring, is going to have a radius of 1 and 1 more, which is 2. So 2 squared, which would be 4 pi. But then we have to subtract the 1 pi area of the bullseye. So 4 pi minus 1 pi, which will leave us with 3 pi for the area of the ring. There's going to be a pattern as we keep going, and you should be able to see it, which is kind of cool. So the next one is the 3 ring, which is 3-inch radius. 3 squared would be 9 pi. And then 4 squared would be 16 pi. 5 squared would be 25 pi, right? So these are just going to be perfect squares of pi, right? And then the area of the ring, we're just subtracting the previous one. So this is the difference between consecutive perfect squares. So 9 minus 4 would be 5, and then 16 minus 9 would be 7. You notice the pattern? 1, 3, 5, 7. Right, it's just every other number, right? They're consecutive odd numbers, which is kind of cool. So the difference between consecutive perfect squares is going to be odd numbers, consecutive odd numbers. Now we could actually prove that with doing like n squared minus n minus 1 squared, where n is an integer, and using the principle of mathematical induction. So if it works for the first ring and then each additional one, we assume it's true. Anyway, my Foundations of Advanced Math professor from college would be very proud of me. It would be that difficult to prove why this is. I mean, first we notice that it occurs in nature, and then we conjecture why it might happen, and then we go about proving that it'll always happen and it'll continue to keep happening. And that's really, really high-level math. So anyway, my brain really enjoyed that little exercise. All right, so the next one, of course, would have to be 9 pi. And it is 25 minus 16 is 9 pi. All right, so now that we have the areas of the rings, what's the area of the whole thing? Well, the 5 ring has a radius of 5. 5 squared would be 25 pi. So the total area of the circle of the dartboard is 25 pi. So to find the probability a dart thrown at random would be a bullseye would be the area of the ring, which is 1 pi out of the total 25 pi. So that fraction would be written like this. So 1 out of 25, which when we put in our calculator is going to be about 4%. Okay, so then the next one would be 3 out of 25. 3 out of 25, which is 12%. And then after that would be 5 out of 25, 7 out of 25, 9 out of 25, just kind of filling in stuff. When we have this kind of algorithm and patterns going, this is when you really want to put this stuff in Excel, because you can just click and drag and make a formula and it'll fill in the values for you. That's why I like organizing the whole thing in a table. It makes it easy. Okay, so what happens after that? 5 out of 25 is 20%. That's a fifth, right? And then we got 28%. Do you notice something going on here? There's like patterns inside the patterns inside of patterns. I know, Illuminati confirmed. 4, 12, 20, 28. We're increasing by 8% each time. So what should come next? 36, right? And it does. Huh. Well, the reason for that is the same reason when we have difference of consecutive perfect squares giving us odd numbers, right? So plus 2 each time. So that plus 2 is going to be 2 more 25ths, which is 8%. So an additional 8% each time. So it's just the same pattern that came about from the difference between consecutive perfect squares. Wow, that was cool. My brain hurts. Not really, but I know yours does. That's okay. It's good for you. That's how you know that you're learning. If you exercise and the next day you're not sore, you didn't really exercise. So if your brain doesn't hurt, then that means you're not growing, and I'm not challenging you enough. Number 17, pizza. All right, so I looked up the prices, the menu prices at Papa John's, and you pretty much never pay full menu price unless you're a sucker. Anyway, so we got small, medium, large, and extra large. Here's our prices, menu prices. And then it's like MSRP or whatever. And then I looked up the diameters. I had to get some insider information from Reddit, from people who work there. I don't know why they don't post this, but anyway, it's 10-inch diameter, 12, 14, and 16 for small, medium, large, and extra large. So we want to figure out, the natural question is, which one is the best value? So what size pizza with its given price gives you the best price per square inch? So again, organize as a table here. Let's find the area. So if we have a diameter of 10 inches, the radius would be 5. So the area, 5 squared, which would be 25 pi. Okay, diameter of 12, so radius is 6. 6 squared would be 36 pi. And you'll notice it's just perfect squares. There's a pattern here. We're increasing a diameter of 2 inches, so the radius increases by 1. So we just go to the next perfect square. So 7 squared would be 49 pi, and then 8 squared would be 64 pi. All right, so that's our area. Now we want to find what is the price that we're paying per square inch of pizza, or like a bite of pizza, which is kind of cool. A small bite of pizza. I wonder how many square inches are in the pizza that I bite. That's an interesting question. I actually have a small mouth. I talk a lot, but I have a small mouth. It's really quite amazing. All right, so price per square inch. So we're going to take the price, $12, divided by the area of 25 pi, which is going to give us about 15 cents. So we're paying 15 cents per square inch whenever we order a small pizza from Papa John's at a regular price. Okay, what about for a medium pizza? By the way, conjecture, which one of these do you think is the best price? So is it always best to buy in bulk, right? Or sometimes bulk is not the same. So our diameter, this is interesting. Our diameter is increasing by 2 inches each time, but the price increases by $2 each time. But wait, what happens in the last one? The XL, they charge a $3 difference to upgrade from large to extra large. So which one is the best deal? This is increasing linearly, but this isn't linear, and then all of a sudden we get something weird going on here. How does the area increase? Well, consecutive perfect squares, that's not necessarily linear. In fact, that's quadratic because it's x squared, right? Y is equal to x squared. We're just starting at 5 when x is 5, so piecewise function from 5 to 8. So our area is increasing exponentially. Increasing, that's a new word. The price seems to be increasing linearly until the end. It jumps to $3, which is like 150% of what we were doing before, right? So which one do you think is the best price? So maybe you're thinking large because in the extra large they start, it's $3 more instead of only $2 more. I don't know. Let's see. That is such an interesting question. So medium price per square inch is going to be 14 divided by 36 pi, which is approximately 12 cents per square inch. And then 16 divided, so it is cheaper. Large is going to be 16 divided by 49 pi, which is 10 cents per square inch. So that is even cheaper. And what happens, drum roll please, 19 divided by 64 pi, is it going to be more or less than 10? I don't know. I do know. Slightly cheaper than large. So 9.4. So what's happening there? And now I kind of wish that I had a graphic, and I'll probably do that for next year. But the difference whenever we are comparing a linear graph to a curved graph kind of gave us the reason why the XL, why we'd expect the prices to drop, as or at least the unit price per square inch to decrease, because our prices were not growing exponentially. They were growing linearly for the most part, while the area was growing exponentially, which is really, really cool.